Hello everyone, welcome back to my channel. I am Ranjit JS, a CSE student from Swankeshwara College of Engineering, Bengaluru. Currently I am studying in second semester. Now in this video we are going to discuss a topic related to mathematics-2 for CSE stream. And the topic is vector line integration. Now let us see the introduction. Vector line integration is a powerful tool used in mathematics and physics to find the total effect of vector field along a curve or path. It involves integrating a vector field over a given curve to calculate the work done, flux, circulation, or other quantities. Vector line integration is represented by the line integral symbol, that is phi, and is an extension of regular integration to multiple dimensions. Line integrals. Line integrals are used to calculate the work done by a force along a curve. We will explore how to evaluate line integrals of scalar and vector fields, including how to parameterize curves and calculate the dot product. Now let us see the fundamental concepts. A vector field is a function that assigns a vector to each point in a given space. The line integral of a vector field along a curve measures the total effect of the vector field along that curve. The curve can be defined parametrically or by a set of equations. Line integrals in two dimensions. In two dimensions, a line integral calculates the work done by a vector field along a curve in the xy plane. It is calculated by integrating the dot product of the vector field and the tangent vector of the curve over the curve's parameterization. Line integrals in two dimensions can be evaluated using either the parametric form or the path-independent form, depending on the circumstances. Line integrals in three dimensions. In three dimensions, a line integral calculates the work and work done by a vector field along a curve in the space. The line integrals is computed similarly to the two-dimension case, but with an additional components of z coordinates, that is z-axis. It is important to choose an appropriate parameterization for the curve to ensure accurate calculations. Let us see the conservative field. A conservative field is a vector field where the line integrals is independent of the path taken. We will discuss the properties of conservative field, including how to identify them and how to use them to calculate work and potential energy. Non-conservative field. Non-conservative fields are vector fields where the line integrals is path dependent. We will explore how to calculate the work and circulation in non-conservative fields, including how to use the curl and Stokes theorem. Now let us see the types of line integrals. There are different types of line integrals, including the work integral, circulation integral, and flux integral. The work integral calculates the work done by a vector field along a curve, representing the energy transfer. The circulation integrals measures the circulation or flow of a vector field around a closed curve. Now let us see how to calculate the line integrals. To calculate line integral, we first need to parameterize the curve by specifying a function that describes its position. Next, we compute the tangent vector to the curve and evaluate the dot product with the vector field. Finally, we integrate the dot product over the parameter range of the curve to obtain the line integral. Calculating scalar line integrals. To calculate a scalar line integral, we need to multiply the scalar field by the different length of the curve and integrate over the curve. The result is a scalar value representing the total effect of the scalar field along the curve. Scalar line integrals can be evaluated using various techniques such as using parametric equations or converting to a double integral. Calculating vector line integrals. Vector line integrals involve integrating each component of the vector field separately. We multiply each component by the differential length of the curve and integrate over the curve. The result is a vector value representing the total effect of the vector field along the curve. Now let us see the path independence. Path independence occurs when the value of the vector line integrals is the same for all curves connecting the same endpoints. A vector field is conservative if its vector line integral is path independent. Path independent allows us to determine the potential function for a conservative vector field. Now let us see what is Green's theorem. Green's theorem relates a line integral around a simple closed curve to a double integral over the region enclosed by the curve. It states that the line integrals of the vector field around a curve is equal to the double integral of the curl of the vector field over the region. Green's theorem is a powerful tool that simplifies the calculation of line integrals in certain cases. Now let us see the Stokes theorem. Stokes' theorem relates a line integral around a closed curve to a surface integral over a surface bounded by the curve. It states that the line integral of the vector field around a closed curve is equal to the surface integral of the curl of the vector field over the surface. Stokes' theorem is a generalization of Green's theorem to three dimensions and is useful for calculating line integrals in more complex scenarios. Now let us see some of the applications of vector line integration. Vector line integration has numerous applications in physics, such as calculating the work done by a force field or the flow of fluids. It is used to determine the circulation of a magnetic field in electromagnetism. Vector line integration is also utilized in fluid dynamics to study fluid flow and analyze the behavior of fluids. Now let us see the challenges and considerations. Computing line integrals can be complex, especially in three dimensions, and may require advanced mathematical techniques for solving. The choice of parameterization can significantly impact the accuracy and ease of calculation. It is important to understand the properties of the vector field and the curve to select the appropriate type of line integral. Now we have reached the end part of the video. Summary and conclusion. Vector line integration is a valuable tool for calculating various quantities related to vector field along curves. It allows us to determine the work done, circulation or flux of a vector field over a given curve or surface. Green's theorem and Stokes' theorem provide powerful relationships that simplify the calculation of line integrals in specific scenarios. Thank you. Thank you for watching the video.